Hi, everyone. I'm excited today to be joined here by Madhu. We are here for Elasticsearch in 3 days, session number 1. I would just let you know that these sessions will take place across 3 days. Today is the first. We will also have one tomorrow on Wednesday, 29th of March, and the final session on Thursday, the 30th of March. Madhu is Principal Lead Engineer at EBRD. He is a trainer and author of several books, including the second edition of Elasticsearch in Action. And that makes him the perfect person to cover the fundamentals of Elasticsearch in 3 days. I'd also like to let you know that our comment section is open. So we will have time at the end for any questions you have, but also feel free to ask any of those questions throughout as well, and I will be monitoring that. Madhu, I think you need to pop on your share screen there at the bottom, and I can add it then to the stream for us. So if you want to just pop that on, then we can begin.
Okay, I'm just sharing my screen. Could you see that noise?
Yes, it's here, and I will add that to the stream now. Perfect, and I'll let you take it away, Madhu. I'll go to full screen.
Yeah, lovely. Thanks a lot. Hi, everyone. Welcome to the Elasticsearch in 3 days. Thank you very much, Niles, for the lovely introduction there. This is a 3-day session. Most likely, you will run away with a little bit of fundamentals, a little bit of architecture, a bit of a code on hands-on code, and hopefully, I'm expecting that by end of Thursday, you will have, if you have come up here as a beginner, you will have a little bit of understanding of what Elasticsearch is, how exactly it's working behind the scenes, and what exactly it can do to you, and how exactly you can onboard this particular the product. Is a really awesome product. I would certainly suggest that there's a lot of career aspects on this one. I would really strongly suggest, if at all, if you're inclined into the search industry, probably this is the best product to pick up anyway. So I have a lot of slides here, but I'm not going to be going through the slides a lot. Instead, what I do is that I'll switch between slides and most likely on the hands-on examples. So probably if I'm in between the slides, just do bear with me on that. So to begin with, so basically, you may have done booking a cab or something like that in the last a month or two, or a last week or so from Uber, and probably most likely, I'm pretty sure if you're an engineer, you may have searched for a code snippet or some sort of a bug description on GitHub or even Stack Overflow. You may have received an email from Netflix, or you bought a theater ticket from Ticketmaster. These are all including the New York Times, actually 164 years of news articles from the New York Times. Probably, I have booked my room actually recently from booking.com recently, I think a couple of months back. And obviously I don't use Tinder, but you can always swipe left or right to find out your love, right? These are all the applications. There is a commonality, and most likely you may be using these technologies, or you may be using these products in one form or the other, but there's one common thread across all of this. These are all powered by Elasticsearch. The power in the search engine behind all these products, the tech products, what you have been through, what you've been using, that is actually really, this is not just the list of products. There are so many thousands of products, thousands of clients using Elasticsearch in their workplace, in their organizations, in their personal, private, any of those spaces you can think of. So just to give you a very simple and high-level example, high-level definition of Elasticsearch, it's a search engine. Certainly it's a search and analytics engine. So you would do certainly the searching side of it, and the second side of the coin is analytics side, because you got plenty of data, you wanted to browse through the data, that is the search. You also have the plenty of data, you wanted to zoom out and see the big picture of what data tells you. That's the intelligence of your data, that's the analytics part of it. Of course, people also use it as a distributed data store, as a database, because it's kind of a highly scalable, highly available, and that's another use case. Most likely most people use it as well, although I don't prefer that as the main thing, technical feature. But search and analytics engine is certainly the most important thing that you take it away from here. The data, what it can hold, is certainly structured. That is the data, something like dates, something like range, something like numbers, etc. That's the structured data which has got a form or got a shape. that can be held in Elasticsearch, that can be searched through Elasticsearch just like a normal database. You can also use this unstructured data. For example, the database, the data where you have certainly there's no form, there's no shape. For example, it could be a blog post, it could be a video file, it could be any of the information on the research article about COVID or whatever it is, right? And also the location information, geospatial, and all those things, that's all can be part of Elasticsearch. They can be held in Elasticsearch. You can browse through, you can search through the data in Elasticsearch of any of this kind of this types of tests, right? Obviously, it used to be an open source. Recently, I think in 21, if I'm not mistaken, it has changed its licensing terms. It's now called as a dual license, open and free. Basically, a server side, the public license and elastic license, I think is over after 7.11. So pretty much it is open and it is free. If you're a committer or if you're a contributor or if you're a developer, you can certainly see the code. You can certainly write your PRs, but most likely what happens is that the PRs needs to be approved by the Elastic people. So that's the only difference between that. There is a long story why it has been moved from open source to open and free or dual license. Something probably you should be able to pick it up online with different forums anyway. There are a couple of competitors actually. Just before I go to competitors, there's one particular product I must mention is the Apache Lucene. Lucene, I think duck cuttings. This is a product which was it's a text library written completely in Java. Is I think it's 1999 if I'm not mistaken. That was the time where that particular product was released, and that is an open source framework, open source library for text searching. So basically, all your full text, your free text, free form of the data that can be searched using your Apache Lucene product, right? So obviously, Shai, who is the founder of Elasticsearch, founder of Elastic Company rather, he took this Lucene, he wrapped around the distributed architecture, distributed features around that one, making the RESTful APIs around it, created this Elastic product. So that's basically the heart and soul of obviously Elasticsearch is your Apache Lucene. There are two competitors, I could say. I mean, there are multiple others as well. The Apache Solar is one of the most predominantly used product as well. In the recent times, I think Amazon AWS has created a open search, a new product called open search. This is obviously this is the birth of a new open source engine based on once Elasticsearch has changed their licensing term, they forked up 7.11 and then 7.10 actually, and then they created a new service called OpenSearch, right? So, but there are multiple other products as well, which we don't need to worry that much at this point of time. But in all, Elasticsearch, there are three components or three parts to that actually. What exactly it's going to do is that it's going to be really big on search, obviously search analytics. It's also big on the application performance and management side of things, so observability and the monitoring side of it. And the final part is the security. So these are the three parts, three modules that you will straight away get into when you start using the Elasticsearch. So you could use it for searching, you could use it for observability of your applications, of your infrastructure, of your of the estate of code, so estate of any of your applications around that, including the monitoring side of things, and of course the security side of things as well. So to find out what are the anomalies, or is there anything that could be hacker attacks or any of that on your infrastructure can be analyzed as well using Elasticsearch, right? I mean, there's a long list of features I can go on and on, but I think the fundamental thing I could say is that, obviously is the search engine. It gives you the basic to advanced to complicated to complex searches. For example, you can use geospatial search, you can use structured and unstructured search. There are specialized searches as well. There's also just a normal search completion features. For example, auto completion you can do, or it will give you did you mean, or you can give some sort of a suggestions to you when you're typing as well. There's some spelling mistakes problems, like for example fuzzy search, and there's highlighting, there's sorting. All those kind of things are already available for you off the box. You don't need to make that much those kind of things. You don't need to make any changes. It's all already available for you out of the box. On the analytics side and aggregation side, you certainly have a really obviously you are amassing the data. You can start using the analytics on top of that data to find the business, to find the intelligence on that particular data, right? Obviously, anomaly detection is one of the features of Elasticsearch as well. Using the machine learning models, you can use that for that purpose as well. And there's, again, as I said, there are multitude of features that we don't need to worry at all. This is one picture I really want you to take away from here. This is a stack. It's Elastic Stack. Used to be called Elk Stack, but now introduction of the beats is now called as Elastic Stack. On the right hand side, you see the client side where you have Kibana, where you have your own applications, probably maybe external interfacing applications. On the left hand side, you see something called beats. Beats frameworks are nothing but a data shipper, so a single purpose data shipper. So for example, if you have a Apache, let's say a web server running on your machine, on your virtual machine, or in your physical server, then probably that is actually certainly going to spit out some logs, and you want those logs to be exported into some sort of a centralized logging server, like maybe it's Elasticsearch or maybe a Splunk or any of that sort. Then in that case, you could use a Filebeat on that server. Filebeat will collect those logs, it's kind of tailing those logs, and then push that into a next level of processor. It could be data, it could be Logstash, or it could be directly to the Elasticsearch as well. Similarly, you can have metrics beat as well as heartbeat and other beats as well. So that's the single purpose data shippers. That means they only do one particular thing, and they only do that is their purpose, right? On the in between those two parts, these data shippers and the clients, you have the heart and soul of Elastic Stack, which is the Elasticsearch, where you are expected to index your data, where you expect you to collect your data, and expected to be serving the data to the clients as and when they require. So basically using the search and analytics part of it. The Logstash in just in a line is basically is a processing engine, is some sort of a ETL processor. So you can talk to multitude of inputs. So for example, if you want to get the data from Kafka, if you want to get the data from S3 into Elasticsearch, or if you want to get the data from let's say a database into Elasticsearch, you can use that Logstash. That is a processing engine. It could do the manipulation of your data when it's coming through the input sources into the outside destination. So there are about 200 or 300 input plugins as well as the output plugins that will support. So it's really one of the best ever, I should say, ETL engine. You could use it without having to worry about integrating yourself or tying yourself into Elastic Stack products, right? So that's another product which you should always think about it. So the Elasticsearch is the core that we are going to look at it here. This particular one, as you can see, is a distributed search engine. That means you are expected to get the data. I mean, obviously, you can distribute your data if you're running your cloud, and if your Elasticsearch is established across the cloud, maybe you could have it running a cluster across multiple regions as well. So you are certainly going to be getting the scalability straight away of the cloud. Now, just final thing before we jump on to a couple of slides, sorry, a couple of hands-on examples. The first thing I would like to do is that it's a complex one. It's a complex piece. I must admit, it's a really complex piece. But the beauty is that you pick up the binary, you unzip the binary, and it should work straight away off the box. Of course, well, just one or two properties needs to be changed, but it should work out straight away off the box. It's really thing of a beauty, I must say. And I think they one of the reasons I always say is that is basically the product actually. I'm from a background where I worked with really beastly components. So, for example, JMS servers and EJBs or enterprise Java bean servers. So I do see the the beauty when an architecture or when a product has been really designed to the liking of how easily you can do that, how easily you can bring up a server. You don't need to wait for 5 minutes to boot up. It's just there actually. So it's always straight away there, right? And it scales easily. You can get your data scaled from gigabytes to terabytes to petabytes. It's up to you. It's really easy. All you have to do is that keep adding more nodes in that cluster, and it kind of gets your data distributed equally and scales up really very heavily, right? And final thing is the RESTful access. One of the best ever design decisions on this architecture, on this Elastic product, is that the the server, the engine is exposing itself, everything, all the APIs by RESTful endpoints. So all you do is that using the HTTP as a transport, you are actually going to talk to the server using your RESTful endpoints. And most likely you may be working with a Python, you may be working with C Sharp, Java, any of those things. They will certainly have a module to support the RESTful access, right? So that means you are expected to talk to Elasticsearch without having to worry about creating a Java based technology or Java based API, Java based framework to talk to Elasticsearch. So the reason I'm saying that is that Elasticsearch is actually built in using Java, but you don't, your client, you don't need to be a Java client. You could have any non-Java client as well talking to that one, because of the RESTful nature of the access on that. So it's a very consistent and congruent APIs are provided to us. It's one of the most important aspects of a beautiful architecture, I must say. Okay, so if I go, I think I just wanted to mention it to you, how we are going to go with the that aside. Now we've just seen a little bit of what Elasticsearch is all about. What I wanted to go forward is basically how do you install, and probably a little bit of a demo as well. Obviously, Elasticsearch is really fast, rapid when it comes to releases. So probably by the time you see this video 1 year down the line, it could have been going to nine version or so. But at this point of time, I think you can go on to downloads Elasticsearch, slash downloads slash Elasticsearch, and go to get your 8.6. I think, if I'm not mistaken, it's 2. So is for the Kibana as well. So we are going to work with 2 binaries today, Elasticsearch and Kibana. Obviously, there are multitude of ways. I mean, normally you wouldn't work in a production system. You wouldn't go by downloading a binary on your production systems. Instead, you may be using package managers or using Terraform to deploy your infrastructure, some sort of infrastructure, right? But you could use a binary, you could use a Docker, you could use a package manager such as apt-get or Yum or any of that to do the job of getting up your Elasticsearch. Right. So let me quickly go over to the Elasticsearch setup. I don't need to get quickly. I mean, I really don't need to show you everything, but all I wanted to show you is that, go on to the downloads folder, and you should be able to see pretty much Elasticsearch. If I can increase the space, unzip your folder, and you should see some folder like this. In this one, you should be able to see Elasticsearch shell scripts, or if you go a little bit further along, you should be able to see some modules, something like this. This is currently I'm running on my local machine. Obviously, if you are running a Docker, you should be able to log into the Docker and find out this similar kind of setup. Or if you're running in a cloud, you will have a different, similar kind of a setup, but in different nodes. But at this point, if I'm only running the a local single node cluster, so something you don't need to worry that much at this point of time, because of the testing, we can certainly development and testing can be done on a single node anyway. Same thing with the Kibana as well. You just unzip the Kibana. That should kick off the Kibana, and you should be able to straight away go over there. Elasticsearch is actually exposing itself on a default port 9200. So once you go to your local host 9200, you should see some sort of a JSON output which tells you that what is the state of the Elasticsearch. So at this point of time, Elasticsearch is telling me that I'm running on my Mac Mini local. It's the cluster name is so and so, and rest of them is what is the version I'm running on at the moment. So that means I have an Elasticsearch server up and running. Pretty good. That's really one of the easiest way to get it up and running. As you can see, as I was telling you earlier, Elasticsearch is built on top of the Lucene. As you can see, that is the 9.4.2 version of Lucene. Now, while you're here, this is basically 9200 is the Elasticsearch port that is exposing. So you could straight away talk to the Elasticsearch as well. However, you should be able to use something called some sort of a cat API. So if you can use this one, I think I may be able to get that cat API. Actually, I just want to show you in a second. Once, let me go back to the console here. I go back to console actually, right? There is something called 5601. In the 5601, what I would do is that I would normally 5601 is the Kibana's GLTH. Sorry, let me do that. and health. That's the one. So if you see the cat API, cat is a compact and alignment text API, which tells you the health of your Elasticsearch. So in this case, it's telling me that it's in a yellow state. But if you use the verbose, it tells you this is a cluster, which is Elasticsearch, and the state is being yellow, and you have one node, which tells you, etc. There are about 29, 24 unassigned nodes, and that's one of the reasons why you have the status being yellow, because whenever you have your running single node, single node has, I mean, I think I'll show you a couple of slides in a minute. When you have a single nodes has got shards, and the shards will have replicas, and replicas will not be able to be assigned on a single node. That means your status is going to be yellow status. But I will show that in a slide in very very shortly. Okay, so that's pretty much on the you can run some of the APIs here, but ultimately this cat APIs are about two to three dozens of cat APIs are there. You should be able to talk to, this is basically you're talking directly to the Elasticsearch, getting the information from that Elasticsearch directly to you, right? However, normally because Elasticsearch is exposing all the APIs via the JT, via RESTful endpoints, you are expected to use some sort of a client API. So for example, in this case, I have a Kibana being one of the clients, which I am running Kibana. As you already know, that Kibana is running on my local machine, which is exposing itself on, it's a web server, it's a Node.js based web server, which is exposing itself on 5601 port. So when I go to my local host 5601, you should be able to see a beautifully it's a feature rich UI given to us, which is basically nothing but called Kibana, right? So this is your home of Kibana. You should see that actually there are there are multiple options here. Most likely we'll be spending most of our time on the dev tools. This is your management side of things, but you can always go on to the dashboards for creating creating a new visualizations, or working with existing dashboards. So now there's a lot more things that you can do on the other bits, but of course we are going to be interested in the dev tools. So if you go on to the dev tools, let me show you once again. Go on to the hamburger menu, go on to the management, and go to the dev tools. Or you can also go on to like here as well, there's a link, you can go on to the dev tools from there as well, right? So here is where you see two panes. There's a left hand side pane and the right hand side pane. This is basically where you're writing your queries. So your queries are going to be like talking to your Elasticsearch. What do you want to ask Elasticsearch? Simply say, okay, just go and get me my some sort of a cluster health, right? So let's say I want to run the same thing, whatever I got it here, cat API's health. I'm just going to use a cluster health here. So I'm just going to use an API called cluster, and I'm just going to say that this is my endpoint. Can you go and get me the health of the cluster? As you can see, this has got three parts. One is your the method itself. So in this case, the HTTP get, HTTP put, post, all those methods are the ones which are going to be invoking your APIs. And there is a little bit of the good thing about Kibana is that it is going to hide you where your local host or where your Elasticsearch is running. But if you go on to your little spanner there, if you copy this particular command as curl, you should be able to see that particular let me clear this. Actually, let me this one. If you can see, that's your curl command. So this part is actually going to be certainly hidden away from you, that you don't need to worry at all, right? At this point of time, it's just simply saying that go and get me the cluster's health by invoking this particular endpoint, right? And where is this going to be calling it? Is going to be the query is actually going to be executed or is going to be sent to the Elasticsearch, which is basically running on the 9200. So from your web server, it's actually going into the 9200. There's a Elasticsearch server executing that health, and that particular server is now responding to you to say that this is my status. This is the information about me. It says that it's my status is being yellow. For, as I said to you earlier, that's because there are some unassigned shards, and that's one of the reasons why I am trying to do that one. So someone has asked me a question here to say, can you explain to me what is Apache Lucene? Very quickly, DI or D, whatever you call. Basically, Apache Lucene is a text library, is an open source Java-based text library. So if you are, for example, building a purely Java search engine, you don't need to use Elasticsearch. Hopefully, Shai is not going to be happy with me by saying that, but you don't need to use the Elasticsearch. You kind of use the Java-based text library. It's a library. You can integrate it into your own search engine. You can invoke it via its APIs and then go with the full text and term queries on that one, right? Structured and non-structured, unstructured data queries on that, right? So it's kind of it's full-blown text library, text search library, that is developed in Java, exposes API. So if you want to use it, certainly you can use it. But the downside of that one is that it doesn't have the distributed nature, it doesn't have the scalability, it doesn't have those kind of features that you are expected to be running as an enterprise search engine, right? And that's where your Elasticsearch is actually going to come into picture. Okay, so let's jump back again onto Elasticsearch, what we are trying to do here. I mean, I've kind of briefly gone through the setup of the Elasticsearch. Let's quickly go on to see um, the, let me show you one quick thing. Yeah, that's the one. I just want to show you this one, and then I'll go back to a little bit of, so not sharing, that's not the one. This one. Okay. So there are some building blocks that you got to understand before jumping into Elasticsearch. The first thing is that every piece of document, every piece of information that you want to store in Elasticsearch, that is actually going to be held or is going to be composed as a JSON based document or a JSON document. So basically, if you think about a database hosts everything or holds everything as row of data, including like a row of data across columns, right? So in Elasticsearch is a NoSQL database, NoSQL search engine. So basically, all your data is actually going to be contained in a specific document, which is nothing but a JSON based document. You throw all these documents into your Elasticsearch into an index. Index is a collection of similar or kind of a document, so similar bucket. So what I mean similar is basically, like for example, if you're creating a table of students, if you're creating table of cities, that is table is called an index in Elasticsearch, whereas table in the database, right? So all your students are the documents, which is nothing but for each and every student you will have a JSON based document. Now, this is an index, but that is an index is a collection of all these documents. However, that is a logical collection, because at the end of the day, index is actually going to be spread or is going to be composed of some sort of a shard. And this is what the shard is, nothing but a physical instance of your Apache Lucene. I know I'm just going to explain to you a little bit later down probably tomorrow. We'll go into a little bit detail to say what exactly shard can do for us. But ultimately, shard is a physical instance of Apache Lucene, which is basically maintained by a collection of or maintained by an index. So for each of the index, you will have multiple shards, maybe one shard, maybe 10 shards, depending upon how you want to distribute your data. And all these shards will host your documents, right? So basically, anytime you index your data, that data is actually going to be composed into a JSON based document, and that is going to go into your index. That means actually they're going to be stored on the shard. And where do the shard exist? They exist on a node. And what is a node? Node is nothing but an Elasticsearch instance. So if I run my Elasticsearch, that is my node. I mean, you can run two nodes, three nodes, depends upon how you want to create a cluster. That's what's a cluster. Cluster is again, is a combination of nodes making it into cluster. So in this case, as you can see, the first picture depicts a single node where you only have one node. In this case, on my local machine, I only have one node which is running at this point of time. That's why I call it as a single node cluster. The minute you start up your Elasticsearch application, is going to create and automatically it's going to create a cluster with one node, because it doesn't have any more nodes coming in joining it. But it's a single node cluster. It certainly is going to form a cluster, but only with one single node. But if you keep adding more nodes to that, even if I can also add 2 or 3 more nodes in my own local machine, that in that case, of course, you have to change a couple of properties when you're bringing up with the same binary. But that's not, I mean, you can see that in the GitHub, which I'm going to share that in a second. Ultimately, the expectation is that you can create a lot number of nodes, and these nodes will form a cluster you will design. I mean, you should have an IT strategy to say how many nodes you should have, how many nodes will form a cluster. Do you want to have multi-node cluster? Those are all up to you how you want to design them, right? So obviously, I'm just going to come back to this slide in a second because I want to show you the working of a document first. So let's suppose I wanted to create a set of students. So this is my first ever time. I don't have a students table, something like you see in the database. You may have to create a student up front, but here I don't have a students database. I mean, I don't have a students document index, right? So what I want to do is that first I want to do is that I want to create a document, right? So I just, let's say this is my document, and this is, let's say, John Doe. Is the name of this my student is John Doe, and probably his age is, let's say, maybe he's 24, right? So that's the document. You can see that it's written in a JSON format. You have name value pairs, nothing fancy there. Now I want to insert this document into Elasticsearch. Normally the operation is called the operation of inserting these documents is called indexing, right? So I want to use obviously is a RESTful interfaces, so that means you are going to be expected to use the HTTP action verbs, right? So in this case, put is my put, or you can use a post as well. I'm just going to use a put, and I need to give a index name. So this is where I wanted to say this is not my index name, and in that index name I need to put a document called something underscore slide document with a particular ID. So let's say the ID being 1. ID is nothing but a primary key. You think of it as John Doe's roll number, for example. um, for the index, let's say I want to create students. This is my index, this is my collection, this is my bucket where all the students are going to go and exist, right? So if I do this one first ever time, because I don't have the students as my collection, is Elasticsearch is going to be, it doesn't moan, it doesn't say, oh, Mr. Konda, you do not have students, so I'm just going to throw away my hands and then start crying. No, it doesn't do that. It's going to go and do the job of honoring your request and start going to create the students, and accordingly is going to insert or index this document. Of course, you can turn that off, that feature, which I would strongly suggest when you're going into production. You don't want to be letting everybody or anybody any request coming in and then start creating an index willy-nilly, right? So in this instance, we created one document, which is pretty good. You can see on the right hand side, you can see that the document has been created. It took about 3.5 seconds for this document to go to Elasticsearch, get indexed, and come back to us, right? So that is pretty good, right? I mean, when I say pretty good, means like it's done the job of getting that right. I mean, you can still go and create if you want. Let's say John Doe's probably girlfriend is Gemma Doe, for example, or maybe so if I do that one, so I got another document created, right? So if you look at it, right, I can still add on the right hand side. If you see, there's something called version, and you can see the result being the creator. This is the first ever time that you're inserting a document, you're indexing the document into the students collection. So that means you're going to create is the result being the created is what spit out. If I press it once again, you are actually going to get, but this time the result is going to be updated, because now you're trying to update the document, right? You can also see that the version has been upped from so for example, in this case, from earlier was 1, is now up to, so you can always keep on, the more you do it, actually the version is going to be increased in that sense. Now, one final thing here. So now actually that's a good thing, right? We started indexing the documents straight away. We don't need to worry at all. We did not think about students index exists or not. We started going and pumping the data. That's perfectly fine. Sometimes you may not don't want to create students with any of for example, um, ID. For like, let's say I want to tweets. I already have tweets, for example. I want to start collecting the tweets, right? In the tweets, I just want to say, I don't want to have any, tweets will come like every so often. I really don't need to maintain an individual ID for that one. So how do I do that one? So probably what you can do is that you can simply say, you can use a post, but you don't need to use the other one. What's it called? Identifier, something like this one. So in this case, I'm not using the identifier. I'm not going to say that this particular student has got, this particular tweet must have an identifier. It will certainly will be I mean, system is going to generate the identifier for us. For example, in this case, you can see that system went ahead and it said, okay, Mr. Konda is giving me a document, and that document does not have a primary key, but I am going to generate one for him so that he is going to be happy, so that I'm going to create this document under this ID, right? Of course, you will not, unless you have this ID, you will not be able to get that document unless you do a search, which is a second, which we are going to see that in the third part, right? So that's basically, you can use the takeaway point is that you can use a put or you can use a post based on your own requirement. If you want the primary keys or if you want the identifiers for that particular document, maybe you should go via the route of using the document identifiers. Okay, that's up to you how you want to take it over from there, right? So while we are here, I mean, of course, you can use, how do you get the document? You can always simply use the same students, for example, same, absolutely same URL. You don't need to do anything at all you're going to do is that instead of put, you're going to use the get, and you should be able to get the document here. Now this document, as you can see, there is some metadata here, and there is some the original data here, right? So you can simply say this metadata tells you that, what is the ID of the document, what is the version, what is the index, etc., etc. I mean, you can always suppress that as well by calling that as just simply source as well. You don't need to, if you really only want source, you can simply say, don't get me the metadata, but just only give me the source, right? So in that case, you can use the endpoint being the source rather than the doc underscore doc. Okay, this is something which is very, very simple, right? I mean, now we index the document, right? However, what exactly the structure behind it? I mean, like, is there any particular structure behind this index? Absolutely, there is a structure. So if I just use, remember, I'm not using any document identifiers here. Instead, I'm actually calling the collection, the get method on the collection on this index itself, right? So on the right hand side, you can see three parts to that, students. So first part is obviously aliases. These are the alternate names given to a student's index. In this case, I don't have any alternate names, but think of it as some sort of a, like, for example, if you have, let's say, 10 types of cars. So let's say vintage cars, old cars, studio cars, etc. But you wanted to create an alias called cars for all of them. So that means you can simply say my cars are going to be combination of all these 10 indices. So that means you can create an alias called cars, which will point out to all these 10. So when you're doing a search, you don't need to search individual car indices. Instead, you can simply say just search on this particular cars index, which will certainly go and get the data from all those 10 individual indices. The second part is basically the mappings. This is something which we will certainly cover that in couple of minutes. I think we got a couple of minutes. Yes. The final part is the settings. Settings is where you are going to tell you, or in fact, you're going to instruct your Elasticsearch to say how many shards do you want, how many replicas do you want, and other routing information as well. So basically, by default, when you're creating a student's index, normally you're expected to create the index with one shard and one replica, right? I did not introduce you to the concept of replicas, but replicas are nothing but, as the name suggests, they are the copies of your data. So as long as you have one shard, which is basically your holder of the data, there should be a one simple replica or the copy of the same thing, one or two or 10, depends on how many replicas do you want to have. Obviously, shards are, the more shards do you have, the better for your search indexing. The more replicas do you have, is better for your read indexing or reading the data quickly, right? So that's the performance side is better for you. It depends actually whether your application is read intensive or this search intensive or indexing intensive. It's up to you how you want to write. Is it write intensive? Um, so coming back to the, I mean, you can certainly change the routing if you want. Sorry, the no routing, the number of shards if you want, or the number of replicas you want when you're creating a index, which we are going to see. I'll just going to show the example, but before I do that one, I want to show you very quickly the mapping side of it as well. If you look at these mappings, I did not tell Elasticsearch to go and find out the data type of this particular property, right? Because when I gave students being X and Y and Z, John Doe name and age so and so, it went through the document. It has deduced the data types by looking at the data value, right? So in this case, it's thought because age has got 23 or 24, that looks like a long, so, or it's kind of a number. So it deduced to be, it said, okay, the age will certainly be, or at least I can think of it as being a type being long. So it went and done the job for us. Similarly, on the name side, name looks like it's a string of characters, John Doe or Gemma Doe. So that means actually they are actually a string of characters. So it said that looks to me like a text type. So I'm just going to certainly going to use the text being the type of it. So it's something which it helped it created automatically. This is something called a dynamic mapping. Where you are expected to get the, or you don't need to do anything at all. The minute you first time you index a document, obviously, if that index doesn't exist, Elasticsearch will take the liberty of browsing through the document, picking up the values, and from that values, it's going to deduce a mapping, deduce a schema, and that schema consists of your properties, your data properties, and the appropriate value. I mean, of course, that could go wrong as well, right? Because sometimes, especially when it comes to dates and other things, Elasticsearch has got certain things that you have to use a ISO date or some sort of a YYYYMMDD. But if it changes from that date, then you will have a problem of getting it wrong. Also, for example, in this case, you really don't need to have a long variable for age, right? You can simply say short, or some sort of a smaller data type. You could have it, right? So that means you can certainly create your own index, right? Your own index with your own mapping, right? So how do you do that one? So you can simply say, I want to put a new index called student2. That's what I'm going to do it. But here I can simply say I'm going to create my own mappings. Mappings is that one of them is obviously say you can just simply say properties. Sorry, properties. Inside the properties, my first one is name, and the type of that one is going to be, let's say this is name. Always maybe you could have it as type as a text, because text is the one of the most important, most most commonly used data type in Elasticsearch, because that holds the full text data, right? So it's kind of a human readable text. If I want to have an age, now I'm just going to create an age, but this time I want to create, instead of long, I may want to create, probably I may want to create, let's say integer, right? So, or you can use short as well, but that's my choice. And if you really want to have additional fields, you can certainly go and do that one. But look at this one. I'm just creating this is my explicitly, I'm setting up the schema. That means you are actually not being at the mercy of Elasticsearch deducing your data. Instead, you are saying that, okay, I want to create my own mapping schema. This is my mapping schema. So Elasticsearch will go and honor that. In addition to mapping, you can certainly create your settings as well. When it comes to settings, you can say that, okay, I don't want the number of replicas be just one, but I want to create number of replicas for this one to be 3, for example. That means for every shard you have, you are going to have 3 replicas created. So that means if you have 10 shards, that means you have 10 times 3, 30 replicas created on X number of nodes, however the nodes you have, right? And keep in mind, whenever you are creating your single replica or single node, those replicas will never be created on the same shard, because obviously there's no point of creating the replicas on the same node or the same server where your shards are there, right? Because if the server goes down along with your the shard, the replicas also can go away, right? That's, you don't want it. So you can also, in addition to number of replicas, you can also say, I want to change my number of shards to, let's say, 2. So that means the students will be held into 2 shards, will be split into 2 shards, and each of these shard will have 3 of these replicas. So you can certainly create your own mapping on that particular part as well. So there are multitude of there are quite a lot of the quite a lot of data types that is available for you. For example, in this case, if I want to create a location, for example, or maybe address, you can always create his address or his location, for example, right? You can just simply say my Mr. Or uh, this student's location could be a geo point. That means we are actually now trying to get the data in the latitude and longitude, that is a geo point as well. That is up to you how you want to manage the data, but there are quite a lot of data types, commonly available data types, from basic to advanced data types as well, available for us. Okay. I'm looking at the time. I think it's almost 45. So probably I'll just take it 5 more minutes, and then we'll continue on that. We'll see if I can take any questions. Okay. So let me jump back onto the slide. In here, what happens is that, let me maximize the slideshow. Very simply, what happens during the indexing is that, you start putting your document into an index. Index is now certainly going into a shard. In this case, a shard. The blue one is the shard. Inside the shard, remember, shard is nothing but your Apache Lucene active instance, which initially the data is going to be copied into an in-memory buffer. That's basically your space in your system, which will certainly going to be every there's a refresh happens, and during the refresh, obviously the documents are going to be moved from in-memory buffer into segments, and then all the segments will be merged and go and I'm going to show you in a second the next slide as well. But all the segments are now going to be pushed back into the file system. Obviously, Elasticsearch is going to use the file system as your data store. That's going to be if you go into the data folder in your Elasticsearch, you should be able to see the nodes data being spit out. This is the merging algorithms. What segments is going to do. So basically, every second, the Apache Lucene comes up and it picks up all the documents which have not been flushed. So it's going to pick up those things. Every 3 segments, or every documents are going to be pushed into a segment, and every time you have 3 segments, it's going to be creating a level 1 segment. For example, in this case, you have level 0 segments, which being 9 of them, and because you have 9, it's going to create 3 segments for each of them, and that means all those level 1 segments are going to be 3 of them. And once you achieve all those 3, then again, level 2 is going to be merged into 1 segment, and then the flush happens after that. That's as simple as that. Now, I can certainly go through this one, but in documents and shards, basically, as I said to you, JSON documents are the ones which are going to be input into Elasticsearch. So you can have multiple indices. In this case, set multiple indices on a node. You can also have each node, each index having multiple shards as well. So this is a Elasticsearch cluster, but you have 3 nodes there. That means actually you have a cluster with 3 nodes, which being on 3 different virtual machines or 3 different servers sitting there. Ideally, what you do is that you create a search service rather than exposing your Elasticsearch to the end clients. Normally, what you do is that you create your own search service, exposing the APIs of just similar to what you see in Kibana, exposing the APIs of Elasticsearch on top of it. So clients sending a request and getting a response back to them, right? Obviously, behind the scenes, you can have Logstash for bits to pump the data in, or you can use the internal analysts, or anyone in the organization want to use some data queries, then you can use the Kibana as well, including the administrators, right? This is another picture which tells you the single node versus multi-node versus multi-cluster multi-node as well. That's a setup you're going to do that one. Now, I think I'm going to run out of time, but probably I will go probably until 7 o'clock. If you look at this particular diagram, all it's going to do is that you have 2 parts to this one. You can do indexing of your data into Elasticsearch via your application, via database, via ETL, whatever the mechanism. So ultimately, you have an indexing service which brings the data into Elasticsearch, because remember, Elasticsearch without data is nothing. You are like talking to a brick wall, right? So you got to have that data in there, and that means you got to start using your existing data, or you're getting the data from an application or a Twitter or wherever you want. You're going to get the data, and the indexing part is certainly going to be the main part to get the data into Elasticsearch. That's your priming part, right? Obviously, the search side is the second part, which where you are going to sorry, the other way around. Search is the one which is going to be used in that one, right? This is something which I'm going to talk to you about the next week, next tomorrow, about the indexing mechanics, when we start looking into a little bit detail on that one. Okay. Now, one last thing I wanted to tell you in the last 2 minutes or 3 minutes is this one: the cluster health. I did mention that the shards are, or at least the cluster health, my cluster health was yellow, right? And the reason for that is that because shards are assigned, however, the replicas aren't assigned. I did mention that to you as well. There are some um, uh, unassigned clusters, right? So you have a very simple traffic-based traffic management system or traffic light management system for your cluster health. Obviously, your cluster, if it is red, you have to start looking at it. I mean, this is kind of a, you cannot sit on your chair to say that, oh, it's red, I'm going to come back and fix it tomorrow. If it's production, you go to jump off and then start fixing it. Obviously expect it to be green all the time, but there are sometimes you may have the yellow, but yellow is something which tells you that is something that is imminent, that you have to look at that cluster health in detail. Just take an example of one node having, this is my node A, having one index spread across three shards, right? So for example, expected to be three shards, but the shard 3 has not yet been instantiated. In this case, the obviously your clustered health is certainly going to be red, right? Because you are not getting all these shards up and running. So that means you still have to wait until the third shard is up and running. Obviously, those you got a problem here, you got to fix it. For whatever there is, a shard 3 is not coming up, so you got to worry about that one. Now let's suppose the shard 3 has come up after a minute or two. That means your shards completely are yeah, I mean are ready for you to do that. However, the expectation here is that you got three shards, but there's no replicas to this one. So that means actually replicas can never be on the same node, because obviously if the node A goes down, replicas are also going to go down. There's no point of you having a backup copy on the same laptop as you have the main data, right? So there's no point of that. So in this instance, the shards certainly are yellow. I mean, sorry, status being shown as yellow. Now let's say you brought up a new node called node B, right? So the minute you bring up a node B, look at what Elasticsearch does. It internally is going to say, oh, I got a new node, so I'm going to copy Mr. Konda's indices of shard 2 and shard 3 onto this node B. So it certainly moved shard 2 and shard 3 onto the second node. However, the status is still yellow because there are no replicas yet. But look at this third one, or the next slide. In this instance, what happens is that because there is a second node, it's going to go and create replicas and copy the data for those replicas. But look at the replicas, how they're created. The shard 1's replica is on the node B, because shard 1 is on node A, replica 1 is on the node B. That is a copy of shard 1. So that is the reason why, as you can see, the shard 1 and the replica 1 are on different nodes, and that means if for whatever the reason, if node B still goes away, you still have the shard 1 data. It's exactly same copy, but you're duplicating the data on a different node. Same thing with shard 2 and shard 3's replicas. They are on the node A as replica 2 and replica 3. Now this is a really happy state. Everybody is happy. So now cluster is absolutely happy. It's going to say, well, this is perfectly fine. I'm just going to be making the cluster as green. So your administrator, yourself, DevOps engineers, all can go and take a sip of coffee and then start for the go for the night very happily. However, let's say there is a crash. Obviously, hardware fails. Your node A is now crashed. Because node A has got shard 1, replica 2, and replica 3, those three are certainly going to be catered for, right? Fortunately, on the node B, remember there's a replica 1 and shard 2 and shard 3. So that replica 1, remember this is the replica which I'm talking about, is now going to be moved, or is going to be changed to shard 1, or is going to be promoted to shard 1. That means your node B is now becoming with three shards, of course, with again no replicas again. That means all your shards are assigned, but replicas are not available. Hence, the cluster state is again yellow, right? So when do you get this one? Again, you have to bring back node A. Then in that case, if the node A comes back, automatically the shards will be moved back into their respective positions. The replicas will be created, and then happy days, right? That's unfortunately until and unless you see that particular time, your shards certainly going to be in a limbo state. Okay, I got to pause there because I think I touched on the mapping as well. I may have to take a couple of questions because of there is quite a few quick questions coming up actually. Um, I think I'm just going to go one by one. I think quite a lot actually, at least few of them. You said usually people create a search service that connects with Elasticsearch not directly, but if Elasticsearch is already open, not secured. Well, you got to be careful here, right? I mean, there are instances of Elasticsearch being open to the public, and there have been hack attempts as well on that. So normally, if I were you, I wouldn't even run that Elasticsearch on 9200. I would certainly, as per my IT strategy, I would internally, part of a VPN, I just create it into a DMZ, make sure that the ports are completely changed, and accordingly, I won't expose that to the external world, right? So search service is expected to be a part of your application gateway or some sort of APIs exposed to the internet. If you are exposing to internet, then your Elasticsearch is completely secured and thrown away, right? Certainly, contact. I wouldn't do that actually on that particular one. Um, so in the follow-up question, contact is asking me, so can't I directly hit the Elasticsearch on 9200? Isn't there any way to directly secure? Well, you can. I mean, as I said, you can certainly enable it as well to the internet. It's not that you can't enable it. I mean, you can just create your own VPN and give the access to the VPN by having those inbound rules if you're working on the AWS or Azure. But you are asking for trouble because remember, Elasticsearch, certainly, you're indexing the data, you're searching through the data, you can do the deleting the indices as well. So I mean, of course, you can do the roles thing, but if you don't do all those things, then you will have a bit of a nightmare to maintain as well. um okay, that's pretty much. And what else I can ask? So Sangyu is saying actually you can secure it using the basic authentication or certificates. Yes, especially in Elasticsearch 8 onwards, Elasticsearch has taken a decision to not to let the security being the second citizen. Instead, the minute you unzip your application or try to install your application, it asks you to do the job of to do the job of what do you call securing your application. I think something which you should always keep in mind to secure application rather than getting a little bit of a problematic in that way. While you had, let me go back to one particular simple thing. There is a Elasticsearch first steps GitHub repository which has got quite a few documentation there. I mean, like lessons there. I would strongly suggest you to go through this one. Like for example, if you're going to go through indexing operations, there's quite a lot of material that you should be able to use it when you're creating this when you're going through these examples. So keep that in mind. That will help you to walk through some of the examples what we are talking about here. Obviously, I won't have all the data, all the examples I cannot run through in this 1 hour, but feel free. There's a lot of material there. You should be able to see a lot of stuff. As you can see on here, there's quite a lot of material that I proposed here, I put in here, so that should help you working through that easily. Okay, so let me come back to questions again. Saying Sangyu is saying it's best if you can go to the documentation site. Probably, I don't know what is the context there, but yeah. Oh yeah, for the latest information, certainly yes, you should reach out to the context anyway. Sorry, reach out to the documentation anyway. Okay. So whenever user makes a search query, so it checks all the indices, or do we mention it in the query? No, you don't mention anything in the query. Obviously, there is a lot more mechanics there actually. So basically, the coordinator node is actually going to find out where exactly this data is held, and is going to call those operations on those nodes or on those shards which are held on those nodes. Certainly your query will never have anything related to which nodes that particular document is or is available or held on. Okay. Israel is asking, can you share this repo? Absolutely, I can. I mean, it's basically yes. You should go to I mean, you should find a lot of my reports. Oh, looks like my connection has been interrupted. Yeah, so something you should be able to see from here. One of my pin libraries, first steps, but there's also other libraries that you could use it. And by the way, while you're here, you can also go into this library, which has got quite a lot of Kibana scripts that you could run it. So very straightforward running. You can just simply copy that. Maybe next that's tomorrow, next class, I'm going to show that you can simply copy all the queries, and then you can run those queries as well without any issues. I think that's pretty much on my side. I need to give away my microphone back to Nayoz. So I'm going to stop my screen share. hopefully there is a lot more to cover as well. Obviously, as you can see, I really want to cover a lot more. 1 hour is actually nothing at all, but I will see you tomorrow, and then we'll go over the a little bit more into details about the search, and probably we'll touch base into advanced search in the third lesson. Back to you, Nurse.
Thanks so much, Madhu. So I know there were a couple of people that joined, I think, or quite a few that joined halfway through. So this will be available to replay on YouTube. If you're watching this after the live stream, this is part of a series of 3 videos. Another one will be coming out tomorrow on Wednesday at 6 p.m. Another on Thursday as well at 6 p.m. So we look forward to seeing you all there. And if anyone has any further questions, feel free to post it in the comments section. And I guess we'll see you tomorrow again, Madhu, at 6 o'clock.
Absolutely. Yes.
Brilliant. That's great. Thanks, everyone.